5.4, dividing polynomials. This section is going to feel a little bit weird. It's definitely much more isolated than stuff that we've seen in chapter 5, but we're going to use it to kind of identify zeros if we need to. So I think it was the last section or the section before it. We talked about the importance of multiplicity and how we can find those intercepts and graph from there. So even though this is a very probably new process for a lot of you, and it seems like a disconnected process, it's not. It is tied to that, finding those zeros, finding those intercepts. So there's a bit of, no, not a bit of review yet. I think that's the next slide. Dividing monomials is the easiest of the cases. In this case, we have a monomial is just a fancy word for a single term. So I have a single term in the bottom of my denominator, and then I have a bunch of terms in my top denominator. And so you can use the process that we're going to see in the next couple of slides for these, but it's a lot more work than need be. To solve these, the easiest way to do it is just break it up into separate fractions. So I've rewritten the question. It's the exact same question. The only difference now is instead of only having one 4x on the bottom of this giant fraction, I have 3 different parts that are fractions with 4x on the bottom. And then from there, just go ahead and reduce. So if I reduce the first term, 12 divided by 4 is 3, x cubed divided by x gets me x squared. And then my next term is 4x squared divided by 4x gets me x. And my final term, and it is kind of important to mention that signs are important. We got to follow those signs. But an error that I see a lot of times with this question is dealing with negatives, or not dealing with negatives, when things cancel. So when you see things, when you're solving like 2x plus 4, if I was solving that equation, I divide both sides by 2, solve, and that 2x, the 2 disappears. It gets canceled. So what's happening there is it isn't really getting canceled, it's becoming 1. So when this canceling happens in this question, when I have 4x divided by 4x, they cancel, sure, but they cancel to be 1. So don't kind of just drop that term out. Leave it there. 4x divided by 4x is 1, and that should be part of your final equation. If you have a term that, like in the last term, if that was just a 4 over 4x, it's okay to leave an x in the denominator as well. So you don't need to have a nice whole number necessarily. It's really breaking up this fraction and simplifying from there. Now, as a bit of review, hopefully at some point in your life you learn how to do long division, or at least you've heard the term. We're going to go through a process of how to do long division with kind of scary polynomials. So we're going to build on those concepts, and maybe along the way on these more complicated examples, you might be thinking, oh, why am I doing that step? You're doing that step because that's the process of long division. So to go through this one, if I was dividing 178 by 3, long division would say, okay, I look at my first term, does 3 fit into it? No. I look at my second term, does 3 fit into 17? Yes. It fits in 5 times, so I put a 5 on the top. I multiply 3 times 5 and put that below the 17, and then I subtract. 17 minus 15 is 2. I bring down the 8. So I'm at 28, and then I repeat the process again. How many times does 3 fit into 28? Well, it fits in 9 times, so that's 27, and then I subtract and I get a 1. And so, yeah, again, maybe if you've seen long division before, you might have been taught that at this point you would add a decimal place, add a 0, and continue your process. But for these type of problem-solving process, we're going to go to probably the very earliest form of long division, in which case we just talk about having a remainder. So in this case, our answer would be 59 with a remainder of 1. Or really what that means is it's 59 plus, and then I have this leftover 1 that was originally supposed to be divided by 3. So it's going to be plus 1/3. So 59 and 1/3. If this went really quickly, it is meant to be a review. So if this is not a review, you're getting a little bit overwhelmed. Definitely this is a good time to pause the video. There are a ton of online resources involving long division. And then once you feel comfortable with that, come back to this lecture. Now, to get a little bit more involved, we are going to divide a polynomial. So in this case, I don't have a monomial. I'm dividing 2x cubed minus 3x squared plus 4x plus 5 by x plus 2. Now, process is very, very similar. The first step is slightly altered, but it's going to feel very similar, and if not anything else, maybe even slightly easier than regular long division. So my first step is I look at the first term of what I'm dividing and the first term of what I'm dividing by. So looking at this problem, I have a 2x cubed under the square root, and not under the square root, under the division symbol, and I have an x on the outside of it. So I think, okay, what can I multiply x by to get 2x cubed? Well, I multiply it by 2x squared. 2x squared times x would get me 2x cubed. Great, so that's good. Now my next step, just like we were doing if it was regular long division, is I would take 2x squared and I would multiply it by both of my terms on the left side of this division symbol. So I do 2x squared times x, 2x squared times 2, and I get 2x cubed plus 4x squared. 2x squared times x is 2x cubed, 2x squared times 2 is 4x squared. Now I'm going to subtract that entire thing, just like we did with long division, and it's a good idea to put this in parentheses, because when we were doing regular division, you were only subtracting one thing, so it made sense to just straight up subtract it, where with polynomial long division, you're going to have more than one term. So make sure that you are putting a parentheses around it and subtracting the entire thing. So just like with long division, at this point, I'm going to subtract. 2x cubed minus 2x cubed cancels. That 4x squared, if I distribute that negative, is actually a minus 4x squared. So negative 3x squared minus 4x squared leaves me with 7x squared. And then I bring down my 4x, and just like with long division, I rinse and repeat. So I think to myself, okay, what can I multiply x by now to get negative 7x squared? Well, it's negative 7x. I multiply negative 7x by x plus 2. That becomes negative 7x squared minus 14x. Oh, there we go. Yeah. Negative 7x squared times 2 would get me negative 14x. Oh my, that's wrong. Huh. Okay, let's see. So now I think, okay, what can I multiply x by to get negative 7x squared? Well, the answer is negative 7x. So negative 7x times x is negative 7x squared, and negative 7x times 2 gets me negative 14x. And I actually pulled this example from the book, and they made an error here that you should probably try and avoid. What they did in one step is they distributed the negative to both terms. So yes, in that step, if you're looking kind of towards the bottom, that should be a negative 14x before you distribute the negative. They were pretty lazy about it and just changed it to a plus immediately. So I know I make a lot of errors in this course, but I actually pulled this one directly from the textbook, so this is not my mistake. Okay, so anyways, I subtract the negative 7x squared and the minus 14x. Negative 7x squareds cancel. 4x plus 14x gets me 18x. I bring down the 5. I repeat one more time. Okay, let's think. What do I multiply x by to get 18x? It's 18. 18x times, or 18 times x gets me 18x, and 18 times 2 gets me 36. I subtract through. Again, they were being very lazy with the notation on this. I subtract through, and so I'll get negative 18x minus 36, which leaves me with negative 31. And now to write my final answer is what's on top of my division symbol, 2x squared minus 7x plus 18, and then it's going to be minus my remainder divided by the thing that I am dividing by. So negative 31 over x plus 2. So that will be my final answer. And now this is a very involved process. This is very tricky. Talking to other algebra teachers, I personally find value in this because this method always works. It's a lot of work. It's very tricky. And you notice in this example, even the book's making errors along the way. So if you're getting overwhelmed with this and you don't love it, you don't have to use polynomial long division in this course. You might see it later on, But for this course, really the only thing we're only going to divide by is binomial terms. And so if I just have two things, if I have an x plus 3 or even a 2x minus 7, the method that we're going to see in the next slide will work. So don't get overwhelmed with this slide. Don't get kind of super lost in the pluses and minuses. Maybe just kind of dive into this concept. So this concept is, like I said, it's kind of limited. It's not limited for this course. This is the only type of division you'll need to know for this course. But it is limited is the one downside. And then the other downside is it's kind of mathematical magic if you don't understand the process. But the process is very easy. It's so much easier than polynomial long division. So even though those first two things are kind of two of my biggest pet peeves in mathematics, the payoff of how nice synthetic division is hard to ignore. And so how synthetic division works is you have to first translate your problem into this kind of weird symbols that we see in front of ourselves. So the question we're going to ask ourselves to do is 4x cubed plus 10x squared minus 7x minus 20. And we're going to divide that by x plus 2. And this might be the same question as the last slide. Not really important. So to translate it into synthetic division, so I always put a box on the top left that we see there, that -2 that's there. What goes in that box is what would be the value if I set my factor equal to 0. Or you would flip the sign of what you would get if you would maybe don't flip the sign. Yeah, just set the x plus 2 equal to 0 and solved. Usually you can get away with just taking the number next to the x and flipping the sign, but that's a dangerous game to play. So x plus 2 equals 0. If I solve for x, I get -2. Whenever you're solving that thing that you're dividing by, that's what goes into your box. Now, these other numbers that seem to be a little bit random are actually pulled directly from the question, from what we're dividing into. So the polynomial I'm dividing into is 4x cubed plus 10x squared minus 7x minus 20. So to translate it, what I do is I really just drop all of the variables and just write it out term by term. So I would have my 4x cubed is now just 4. My 10x squared is now just 10. -6 is just -6, and -20 is just -20. And like I said, this is the hardest part of the process, is understanding the translation. And once you get past that, running through it is very easy and very much worth it. If, let's say, I might run through an example in this later, but if, let's say, I'm missing a term, so let's say my polynomial is 4x cubed minus 6x minus 20, I would just put in a 0 in that spot. So I would place, instead of having my 10 in this write down, I wouldn't just skip the 10 entirely. I would replace it with a 0. So just kind of watch for that if you see that on WebWorks. I don't think we'll try to trick you with that on the test, but I might trick you with that on the in-class worksheet assignment. Okay, now for the process. The process goes that I take my very first term, I drop it down to below that line. It's 4. Nothing fancy with that first step. Now what I do, and this kind of is where it starts to feel a little bit like division, is I take that term on the bottom, I multiply it by the term in the box. So 4 times -2, and then I take that term and put it below my next term. So 4 times -2 is 8. And then I add 2 plus -8 is 2. And then I repeat. 2 times -2 is -4. Add, I get -10. -10 times -2 is 20. Add, I get 0, and I'm done with the process. I am going to have to do a little bit of translation, but I'm done with the process. Now, sometimes what people do with synthetic division is they kind of like to put in this dotted line to keep track of the fact that that very last term is actually your remainder. So you might see that. I wouldn't expect you to do it. I might do it on sometimes, and I might do it in the other, because that's kind of just a preference thing, where everything else is pretty standard with synthetic division. Okay, so now I went through my process, I did my synthetic division, I followed the steps, and now all I have to do is translate it back. And so to translate it back into a polynomial is I would take my original, I look back at my original polynomial that I'm dividing into. I have 4x cubed plus 10x squared minus 6x minus 20. Well, I look at the degree. The degree in that is 3. And so when I go through this dividing process, my new degree will be at most 2. So to translate this back, I just rewrite this as a polynomial, except for each of these are just the coefficients of now I have an x squared breakdown. So I would be left with 4x squared plus 2x minus 10. I drop my degree by 1. And if I didn't have a 0 remainder there, I would account for that and just put whatever that remainder is divided by x plus 2, divided by that divisor. Why did I write a 10 there? Oh. So if there isn't a 0 there, again, this is a hypothetical, so almost imagine this is an entirely different problem. If I didn't have a 0 there, then that is my remainder, and what I would do with that remainder is I would just do 10 over x plus 2. But that's, like I said, that's kind of an offshoot. I would maybe not even write that in your notes because that's not what the original question was. This is more of just a hypothetical. And that's the end of this section.